Sincerely. Okay, so let's take a look at number 43. So 43 said, geometry, write an equation in standard form that models the possible lengths and widths of a rectangle. All right, so we're dealing with a rectangle. All right, so having the same perimeter as a rectangle that is 10 feet wide and 20 feet long. All right, so we have a rectangle that is 10 feet wide and 20 feet long. All right, this is just what a rectangle is going to look like. All right, and they said the perimeter of this rectangle is going to be the same as the perimeter of our rectangle. All right, so I'm just going to draw our rectangle. It's probably going to be a little bit longer than it is wide, just because we need to make up feet here. So this perimeter and this perimeter are going to be equal to each other. You guys with me so far? Okay. So here's my length, here's my width. So it says, write an equation in standard form that models the possible length and widths of rectangles having the same perimeter as this. All right? Well, I can find the perimeter of this one. Because if I can find the perimeter of this one, then I have an equation that I can set up for perimeter for this one. All right, so for my first step is I'm going to find perimeter of, let's call this rectangle 1. We're going to call this rectangle 2 just so I can refer to it. All right, so the perimeter of rectangle 1, well, the perimeter, is 2 times L plus 2 times W. All right, so that's the perimeter formula. No, yes, that's the perimeter formula. I questioned myself for a second. And I'm just going to go ahead and substitute those in. So I have 2 times 20 plus 2 times 10. So I end up with 400 plus, nope, too many zeros, 40 plus 20. So my perimeter is 60 feet. All right, so I found the perimeter of my first rectangle. And we know that the perimeter of the second rectangle is going to be the same perimeter. So Rita, are you cool with that? Okay, so now I can set up an equation for my perimeter of my second rectangle. So I have 60 is equal to 2L plus 2W. So there is my standard form, where L and W are like X and Y. Does that make sense? All right, so if you don't like L and W, how many of you are looking at that and you're like, yeah, but that doesn't look like standard form? How many of you guys would rather see X and Y? Then change it. All right, I'm just going to say my L is my X, my W is my Y. Just tell me what you're changing it to, and I'm good with that because I'm the same as you. I want to see X and Y. I don't want to see C, I don't want to see L, I don't want to see W. I want to see X and Y because that's what I'm used to. So just do that. That's fine with me. All right, so if I rewrote this, 60 is equal to 2x plus 2y. By all means, change it. All right, and then we can graph this. Do we want to make a graph? It says make a table that shows the 5 possible lengths and widths. The only problem with doing a table is that, well, if we have feet, can we have parts of feet? Like, can I have like 5.5 feet and 10.2 feet, right? Okay, so decimals are going to be okay, so I'm not going to make a graph. I am just going to go ahead and make a table because we can have parts of this. All right, because this is even, I might stick with even numbers. I don't know why. I feel like that might be a good idea. Maybe not. All right, so I'm just going to go ahead and make a table. And I'm going to say length. This is feet. And I'm going to say width. And this is feet because I made my width my W, my length my X. All right. I can't, could I use 0 as my length? Could I use 0 as my length? Molly?
No.
Yeah, right? I mean, I can't use 0. So while I could graph this, I would have to graph, if I said graph this, you would have to use your X and Y intercepts. How many of you guys know that if I said graph it? But are your x and y intercepts possibilities? They're not, because you can't have a 0 for a side length. So I'm not even going to use 0. I'm just going to start with 1. Are there any limitations? They said 5 possible lengths and widths. So I'm just going to use 1, 2, 3, 4, and 5 for my lengths. And then I'll just come up with the widths. Does that make sense to you guys? All right, so I'm just going to do 60. I'm going to solve this. I'm going to make my life a lot easier. And I'm going to solve this equation for y. So I can just shove that in and not have to solve every time. So I'm going to take, I have 60 is equal to 2x plus 2y. I'm going to subtract 2x from both sides. So I have negative 2x plus 60 is equal to 2y. Divide each side by 2. So I end up with negative 1x plus 30 is equal to y. So I'm going to use that for my calculations. You didn't have to, but I'm doing the same calculation over and over and over again. I feel like that might be an easier way to do it. If you didn't, that's okay. So I have negative 1 times 1 plus 30 is going to be 29. I have negative 1 times 2 plus 30. So this is negative 2 plus 30, which gives me 28. And then I would go from there. No, you're not going back in that room. Are you going to get another one? Are you completely finished with that? Do you need to do the bottom parts to this? What about these? Is there something that you're supposed to do that says right, true, or false? Then on the lines divided, change the false statements to true and make them true. You're telling me that all of these are true? Do you think they're all true? What's the possibility of them all being true? 50% chance. Chances are that they probably aren't all true. Just a thought. But if you are finished and she told you to go ahead and you did this to the best of your abilities, then go ahead and give it to her. But I guarantee you not every one of those are true. I'm just telling you. They did not create those 4 problems where every one of those are true. So think back on those and go back in the book and look for the words and phrases that go with those and see if they're true. Just check them. That's all I'm asking is check them. And if that's the case, yes, but your mouth is going to be zippity-zip closed. You're going to quietly walk in, hand it to her, and you're going to walk back out of the room without making eye contact with anybody. Okay. Are there any other questions? Yes. Make a table that shows 5 possibilities. I don't think there's only 5 possible. They just said limit it to 5. Because technically I could have 1.1 feet, 1.2 feet, 1.3, 1.4. So there's a ton of possibilities. They just said do 5. Is there anything? You're welcome. Is there anything else I can do for you guys? Okay, get your notes out. Let's practice some more. Okay. All right, I want you guys, okay, I'm going to give you, do you guys want hard or not too hard? Hard. All right, so I'm going to give you one. The percentage ones throw me off with the mixtures. You do on your homework tonight have one that has percentages with mixtures. Do the best you can. It's going to be a harder one. I'm going to, let's give you, I think one that's going to be like something in your homework. So I want you to do 20. Just do 20A for right now, just so we all get the equation, and then we'll work on the rest of it from there. Because these are harder, this idea of a percentage of, like a mixture is a percentage of something. Yeah, there's a look on your face, precious. You're looking at it and you're like, oh my gosh. So this is a harder one. So I want you to at least write down the information and maybe we'll walk through this one together. Because this one, a drawing of it is a good idea. Hi. Sweet. Excellent. Addison.
Christiana.
Yep. Oh, yeah, I'll get them to him.
Okay.
Thank you. I do have an idea. These are hard. Like, I even have to remember how to do this. I'm just going on record as saying these are harder. Okay, so we're going to we're going to figure out how to do this one together. Okay? So this tells us that, in fuel, you guys do know that fuel is a mixture of things. Okay. So we have a mixture of gas and oil. All right, it says on standard gas, it's 98% gas, and it is 2% oil. All right, that's our standard. All right, it says the break-in mixture of a new engine is 96, so this is standard. I'm just writing this down. So the break-in, that's when you have a brand new engine. It's 96% gas. You guys asked for a hard one. 4% oil. All right. It says write an equation in standard form that models possible combinations of each mixture for 6 gallons of gas. Now, when they're talking about 6 gallons of gas, they mean 6 gallons of fuel. Not of gasoline. It's fuel. So the total amount that you are preparing are 6 gallons of of the whole thing. Like the whole thing you're creating is 6 gallons. Do you guys understand? Okay. Okay. Yeah. So, let me explain to you how this works. Okay, so I want to show you guys something. Here's my picture. Okay? Well, let's look at this way. Look over here. Here's my bucket that I'm putting 6 gallons of fluid in. You guys with me? So this is my bucket of 6 gallons of fuel. Okay. This is oil. This is gasoline. Okay. I have to take this amount and I have to pour it into here. And I have to pour this amount into here. Only 78% of this is going to be from the gas. Only 2% of this is going to be from the oil. You guys okay? Okay. Normally I see this in my systems and equations. That's where I'm going to find it. Because I have to remember how to do this. Hang on 1 second. No. You just got to give me a second. It's in my systems of equations. Because I've done these in the other one. I told you guys, it's not the easiest thing in the world. So, I just have to remember how to do it. Because you don't do these all the time. Where is it? Hang on. Give me a moment. So, okay, so if we think about this, here is, we have 98% of the total is your gas, right? 2% of your total is your oil. You guys with me? Okay. So what I don't know, I gotta remember how to do this one, because in systems of equations we deal with it 100%. You guys gotta give me a second. I knew I shouldn't have given this to you, because now I gotta figure it out. Okay, I want you guys to try it on your homework, the one that I gave you. I'm not, obviously not. You're not being marked down if you can't figure it out. But let's do one that's a little easier in class. Okay. You asked me for hard. You said hard, and somebody said as hard as you can.
I said not to read still wants it.
All right. Do this one. I am going to figure the other one out. Do this one. I'm determined to figure the other one out because I do remember how to do it. I just got to get back to it because it was in systems of equations, and with the system, it's a little bit different. So do this one.
Joseph, this decade. We said this little 10 times already. Roll behind.
Just move along. Okay, you guys are working on this. So gentlemen in my front row, work on this, please. That's the talking I should hear. Okay, that's what I thought.
Sounds like a robot. It sounds like anything.
You guys are working on math. You're working on math. That makes sense. Yes. So what does X represent? So what does your variable represent that you're finding the intercept of? So it's the number of picks, right? Okay. So you are going to have to round. So I would use your rounding rules on that, right? You can't do half of it. You just round down. I would round down, and then that would give you, you would probably end up rounding. Yes, I would round down. I'm not going to be all that picky about that part of it. Yeah, I would just round down. Walk it through them. Have someone tell you what you're doing. So Maggie and Lily, explain to Elle what you're doing. That's going to help her understand more when she wants to do it. So your X and Y intercepts is going to be decimal. So just round them. It's an approximation. Once you get out of graph, it's an approximation. Yeah. All right. So you can't have a part of a pick. So you are going to have to round down because you can't round it up. Because if you have zero of one pick, and your money total of $5 is spent, and you can only buy 2.5 picks, you can't round it up because then you've gone over. Well, yeah, can you have a partial pick? Can we go around? What did you guys get for your X and Y intercepts? So this is, I'll write the information down in a second for our video watchers. What did you guys get for your X and Y intercepts? Joseph, what did you get for your X intercept? 14, 0. Rita, what did you get for your Y intercept? 0. Excellent. Okay. So X is equal to your number of nylon picks. Is that what you guys are using? You guys make sure when you set your X and Y, it's your number of nylon picks and your number of celluloid picks. Because we're dealing with cost per pick as well. So be very specific with what this information is. So my Y, I have number of nylon picks. And then my Y is my number of celluloid picks. Not just celluloid, not just nylon. Alright, so if I graph these, I'm going to count by 2's on my y-axis. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. So here is 0, 20. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can't do that. Count by 2's. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4. So here is the other one. So I'm going to go ahead and graph this. So that should be our graph. And it said, write an equation, explain the intercepts. All right, so for my x-intercept, what does my x-intercept mean? What does my x-intercept mean, Giselle? Celluloid? Yep. 14 nylon picks, 0 celluloid. Please do not say to me that that is the maximum number of nylon picks you can buy. Be very specific. It's 14 nylon picks, 0 celluloid picks. What does my y-intercept mean? Ashley? Yep. Okay, so then it says list 3 possible combinations. Your combinations could be different than mine, depending on your graph. If you counted by ones, yours might be different. I for sure have a nice one right here. All right, the rest of them aren't quite as nice. I have one that's pretty close to right here. Again, graphing is an approximation. I could have used, I think Rita, you and I talked about this. I could use this point, because it's right around the halfway. Since I'm counting by twos, this point right here, 2, 4, 6, 8, this would be 8 nylon and 9 celluloid. So because I was counting by twos, I could do a halfway, because I don't see, if it said 3 possible combinations, I don't have a nice third one. So halfway does work, because I was counting by twos. Does that make sense to you guys? If I counted by ones, chances are I would have a lot more crossing points. All right, so the smaller you make your increments or the bigger you make your graph, the more likelihood is that you're going to get good crossing points. But again, don't just write this as a coordinate point. So this point right here means 4 nylon picks, and that's 10, 12, 14 celluloid. So you go to your points that you found and label them appropriately with the data. Don't just do this. 10, 6. I will not take that. Unless off to the side you've listed them properly. Does that make sense to you guys? Okay. I think I've tortured you enough. You guys are good to go.